part B, we're going to look at the molecular polarity as well as the bond polarity. So you're going to pull up the simulation. It takes a minute to load, and then we're going to build. You're going to select the real molecule, build the molecule, and then display the dipole moments, the bond dipole as well as the molecular dipole, and then sketch that on the data sheet. So your data sheet looks like this. So you're going to have two. You're going to build water and carbon dioxide build. You're just going to display them, and then you're going to answer some of these questions. But what you want to draw is the bond. You want to actually show the dipole moments. All right, so I'm going to click on real molecules. Then I'm going to click select water, so I get something that looks like this. And the bond dipoles are represented right there in like gray. So remember, the bond dipole is like the difference in electronegativity between the two atoms. So this bond dipole over here is between oxygen and hydrogen, and you can display the electronegativities if you want to, so you can see how different they are. You don't have to, but if you want to, you can do that. And then the molecular dipole kind of takes into consideration the placement of all of the bond dipoles and then adds them up, and it shows you like overall is there a net pull in one direction or not. So in this case, the arrow is always pointing towards the more negative side. So this is the more positive, electropositive, this is more electronegative. And then you kind of break these down, add them all up, and then that is the molecular dipole. So if you see a yellow arrow, that means your molecule is polar. There is a difference in the arrangement of the polar bonds. So on your data sheet, you want to draw that picture. So I would have my water, I would have like my oxygen there, I have my hydrogen over here, and then I have these bond dipoles that are going in this direction, and then overall there's one in that direction. So that would be my molecular dipole, and then those other two are my bond dipoles. And then you do the same thing for carbon dioxide. I should go back and let me show you one that is, this one's not polar, so you can see this is what's the default, and then if you put on the bond dipoles, you can rotate this around the bonds. You can see that CO on both sides, those are equal bonds. They're equal, they're 180 degrees from each other, so they're going to cancel each other out. And when you say display the molecular dipole, it's not there. It's not there because it's non-polar. So if these two bond dipoles cancel each other out, then you're going to end up with something that is non-polar. So you're going to draw that one. You're going to answer some questions about these, and then you're going to compare these two, NH3 and BH3. Again, answer some similar questions. And then you have O2 versus HF. And then finally, this last one, what happens when you take carbon with 4 hydrogens and then start substituting the hydrogens with something else. So this is carbon with 3 hydrogens and 1 fluorine. This is carbon with 1 hydrogen and 3 fluorines. So check out the differences between those, who's polar, who's non-polar, and then just answer those questions.